Hi everyone, so this is the third video on Chapter 5 on one-way ANOVA. In this video I'm going to show you a complete example of analysis of variance doing all the steps in order. Okay, so this is the order I'm showing you in this video is the way you should be doing it on your homework, and also if when you have to do this on an exam. Okay, so first I'm going to show you the data that we're going to be using for this example. I will have a copy of this data posted on Canvas so you can have it to refer to while you're watching the video if you would like. Okay, so this is the data. In this example, we have one group that's listening to classical music while they're studying, and another group that is not listening to music while they're studying. And then after studying, they take a quiz, and their quiz score is recorded. Okay, and so you can see we have 6 people in each group, and those are their quiz scores. Then we have A1, that's the total for group 1, which is 45. A2, which is the total for group 2, which is 49. We also have the sum of y squared. So again, you get the sum of y squared by taking each score and squaring it. So this 355 for the sum of y squared for group 1, you would get that by taking 8 squared, which is 64, plus 6 squared, which is 36, plus 10 squared, which is 100, plus 9 squared, which is 81, plus 5 squared, which is 25, plus 7 squared, which is 49. So if you did that and added them all up, you would get 355. If you do the same procedure for group 2, you would get 403. And then I also have our means here. So the mean for group 1 is 7.5. And the mean for group 2 is 8.17. Okay, so again, group 1 is classical music, group 2 is no music. Okay, so we're going to go back to our notes here. Okay, so first our independent variable is the music condition. Okay, and so our levels are classical music or no music. All right, so what's being manipulated is the music condition. The dependent variable is their quiz score. Okay, or you could think of number correct or points correct on a quiz, something like that. Okay, then we're going to have our null hypothesis. We only have 2 groups, so it's mu1 equals mu2. Our alternative hypothesis is not all mu's are equal. Okay, now since we have only 2 groups, you could write mu1 does not equal mu2, and that would be okay, but if you have more than 2 groups, you have to write it as not all mu's are equal. Okay, so the next thing you should be doing after you write your hypotheses is testing for homogeneity of variance. Okay, so we're going to start that. So just a reminder, F max is what we're going to calculate, and that is going to be S squared largest divided by S squared smallest. Okay, so before we can calculate F max, we need to find our group variances. So we got to find the sum of squares for group 1. And so we're going to do the sum of y squared for group 1 minus the sum of y and parentheses squared divided by n. And so I'm pulling these numbers from that data sheet I just showed you. So the sum of y squared is 355. The sum of y for group 1 was 45. And n was 6. So 355, and then 45 squared is 2025 divided by 6. So now we're going to do the division, and we get 337.5. And now we do the subtraction, and we get 17.5. Still, this is not variance yet. So we have to get our s squared. I'm just going to put a 1 there so remember this is for the first group. So 17.5 divided by 6 minus 1. Okay, and when we do the division, we get 3.5. Okay, so that's the first variance. So that was for classical music. Now we're going to do it for the second group, which is no music. Same formula. So now the calculations from the data sheet are going to be 403 is sum of y squared, and then 49 is the sum of y squared, or sum of y, and then we're going to square it, divided by 6. So 403 minus, and then 49 squared is 2401 divided by 6. So then 403, now we're going to do the division, so minus 400.17. And when you subtract, you get 2.83, okay? To convert that to variance for our second group, it's going to be sum of squares divided by n minus 1. So 2.83 divided by 6 minus 1. So 2.83 divided by 5 equals 0.57. I'm jumping ahead. 0.57. Okay. So we're going to take these numbers, we're going to plug them in. So the largest one is 3.5. The smallest one is 0.57. When we divide, we get 6.14. Okay, so now we compare that 6.14 to 3. Okay, this is bigger than 3. Okay, so just reminders. Okay, since 6.14 is greater than 3, then homogeneity of variance is violated. And you want to write that. That's your interpretation of the test for homogeneity of variance. Okay, so we need to use F adjusted in our decision rule. Okay, just a reminder, so when your F max is large like this is 6.14, here, right? That means that the largest variance is more than 6 times as big as the smallest variance. So that definitely looks like they are not equal, and that's why the assumption is violated, okay? So we need to use the correction. But before we can even look up our critical value for our decision rule, we need to calculate degrees of freedom. So we need to calculate degrees of freedom and state our decision rule. All right. So we want to do degrees of freedom for A. So that's little a minus 1. We have 2 groups, minus 1 equals 1. Then degrees of freedom for S over A is A times n minus 1 in parentheses. So 2 times 6 minus 1, which is 2 times 5 equals 10. And then to check our work, degrees of freedom total equals A times n minus 1, but no parentheses. Okay, so that's 2 times 6 minus 1, so 12 minus 1 equals 11. And you want to check that your degrees of freedom for A plus your degrees of freedom for S over A equals degrees of freedom total. Okay, and so sure enough, 1 plus 10 equals 11. All right, so we're going to say that if alpha is 0.05 in the problem, and so we're going to switch to alpha over 2 because homogeneity of variance was violated. Okay, and just remember, if F max is less than 3, you can stick with your original alpha. Okay, so we want to use 1 and 10 degrees of freedom to look up our critical value for our F adjusted. So I'm going to look up F adjusted, and so let's see if we can find. All right, so this is our chart. Okay, so remember, if alpha is 0.05 in the problem, but homogeneity of variance is violated, we want to use this chart that says alpha equals 0.025. Now, our degrees of freedom for A is 1, so we're going to look in this first column, and degrees of freedom for S over A is 10, so we're going to look here at 10, and our critical value is going to be 6.94. Okay? Oh, I'm jumping around. Okay. So our F adjusted is 6.94. All right. So now our decision rule is if the obtained value of F equals or exceeds our F adjusted, which equals 6.94, we're going to reject the null hypothesis. Otherwise, fail to reject the null hypothesis. Okay, and so remember, we're using this F-adjusted here because we violated the assumption of homogeneity of variance. If we had not violated that, if our Fmax had been less than 3, we would use the table that's in our book with alpha equals 0.05, and we would be calling this F alpha instead of F adjusted. But otherwise, the rule would be written the same way. Okay? All right, so now we want to calculate the F ratio, or F obtained. Okay, this is from our data. And so we're going to get our basic ratios first. So we're going to start with the basic ratio for y. This is going to be sum of y squared. Now, here's a little trick. If you've already done the Fmax, you can just take your sum of y squared that you used for group 1 and your sum of y squared from group 2 and just add them up. So we're going to use 355 and 403 and just add them up. If you don't already have that calculated, you're going to take all 12 of our scores, square each one, and add them up. Okay? So this adds up to 758. Next, we're going to do the basic ratio for A. So this is the sum of A squared over N. So we're going to take the A's. That's the total for each group. Okay, so the total for group 1 is 45. And we're going to square that, plus the total for group 2 is 49. Square that. And our N is 6. So 45 squared is 2,025. And then 2401. We're going to divide that by 6. We add those up, we get 4426 divided by 6. And then we get 737.67. Now we're going to do the last basic ratio for t. So that is t squared over a times n. We can get our t by adding up our a's. So 45 plus 49, we're going to add those and then square it. We have 2 groups with 6 people in each group. So 45 plus 49 is 94 squared over 12. 94 squared is 8836 over 12. And when we divide, we get 736.33. Okay. Now we're going to do our sum of squares for between group, which is sum of squares for A. So remember, that's the basic ratio for A minus the basic ratio for T. So A was 737.67 minus T, which is 736.33. And that comes out to 1.34. Then we're going to do sum of squares for S over A. That's the basic ratio for Y minus the basic ratio for A. So 758 point, oops, no, just 758 minus A, which is 737.67, and that comes out to 20.33. Then to check our work, we do sum of squares total. which is the basic ratio of y minus the basic ratio of t. So that is going to be 758 minus 736.33. And that comes out to 21.67. And so you want to check your work that sum of squares A plus sum of squares S over A should equal sum of squares total. So 1.34 plus 20.33 should equal 21.67. And it does. The other thing you want to check is that they should all be positive values. So remember, these are sum of squares, so the squares means it should all be positive. All right, we're getting close. Okay, so now we're going to do our mean squares. So mean square A equals sum of square A divided by degrees of freedom for A. So our sum of squares for A is 1.34. We did our degrees of freedom earlier. Let's see here. Here it is, 1. So it's still 1.34. Then we're going to do mean square for S over A. So that's the sum of square. Sum of square for S over A divided by degrees of freedom for S over A. So let's see, our sum of square for S over A is 20.33. We want to look up here. Our degree of freedom for S over A is 10. So we're going to divide by 10. So that's 2.03. Okay. Now, to get our F, it's mean square A over mean square S over A. So 1.34 divided by 2.03. That comes out to be 0.66. Okay, that is not good. Anytime you get an F value that is less than 1, you definitely know there's no treatment effect. Okay, but we want to compare that to our decision rule. All right, so here's our decision rule. So if the obtained value, which we have 0.66, equals or exceeds 6.94, reject the null hypothesis. Otherwise, fail to reject. Well, it's definitely not equal to or bigger than 6.94. So we're going to do this otherwise part and fail to reject the null hypothesis. So 0.66 is less than 6.94. So our decision is fail to reject the null hypothesis. Okay, so our conclusion is that the music condition did not have a significant effect on quiz scores. And then we want to give our statistics. So F with 1 and 10 degrees of freedom equals 0.66. And then P is greater than 0.05. Okay, so remember, when you fail to reject the null hypothesis, this means there's no evidence or not enough evidence that we have a treatment effect. Okay, so whether or not people studied listening to classical music or not listening to music. It didn't have an effect on how they did on the quiz. Okay. Our F is 1 and 10 degrees of freedom. The 1 is degrees of freedom for A. The 10 is degrees of freedom for S over A. The 0.66, that's our F that we calculated from our data, okay? Not from the decision rule. This P greater than is because we failed to reject the null hypothesis. It's saying the probability that you would get an F value of 0.66 when the null hypothesis is true is greater than 0.05. It's very likely. So because of that, we are not going to reject the null hypothesis. And just a reminder, that's your alpha, okay, from the problem. All right, so that is our full example. I'm going to stop there. In the next video, I'll be using the exact same data to show you how to do the independent samples t-test. Okay, so that's what's coming next, and that should be the last video for chapter 5.